Welcome to our video lesson on displacement reactions, double displacement reactions, and oxidation reduction reactions. In this lesson, we will conduct a series of activities to understand these concepts and explore their applications in everyday life. Let's begin with activity 1.1, where we will observe a displacement reaction between iron and copper sulfate solution. Take 3 iron nails and clean them by rubbing with sandpaper. Next, take 2 test tubes labeled as A and B and fill each with approximately 10 ml of copper sulfate solution. Tie 2 of the iron nails together with a thread and carefully immerse them in the copper sulfate solution in test tube B for about 20 minutes. Keep 1 iron nail aside for comparison. After 20 minutes, remove the iron nails from the copper sulfate solution and compare the intensity of the blue color in test tubes A and B. Also, compare the color of the iron nails dipped in the solution with the one kept aside. Chemical equation: Fe plus copper 2 sulfate, Uk, right pointing arrow iron 2 sulfate, Uk, plus Cus. The iron nail becomes brownish in color, and the blue color of the copper sulfate solution fades because a displacement reaction has taken place. The iron has displaced or removed copper from the copper sulfate solution, forming iron sulfate and solid copper. Displacement reactions occur when a more reactive element displaces a less reactive element from its compound. Here are a few more examples of displacement reactions. Chemical equations: Zn plus copper 2 sulfate, Uk, right pointing arrow zinc sulfate, Uk, plus Cus, Pb plus copper 2 chloride, Uk, right pointing arrow lead 2 chloride, Uk, plus Cus. Zinc displaces copper from copper sulfate, forming zinc sulfate and solid copper. Similarly, lead displaces copper from copper chloride, forming lead chloride and solid copper. Moving on to double displacement reactions, let's perform activity 1.2. Take about 3 ml of sodium sulfate solution in one test tube and 3 ml of barium chloride solution in another test tube. Mix the two solutions together and observe. You will notice the formation of a white substance, which is insoluble in water. This insoluble substance is called a precipitate. Any reaction that produces a precipitate is known as a precipitation reaction. Chemical equation: sodium sulfate, Uk, plus barium chloride, Uk, right pointing arrow barium sulfate, S, plus 2 sodium chloride, Uk. In this case, sodium sulfate reacts with barium chloride to form barium sulfate, which precipitates, and sodium chloride remains in the solution. This is an example of a double displacement reaction. Now, let's explore oxidation and reduction reactions, also known as redox reactions. In activity 1.3, we will observe the oxidation of copper to copper oxide. Heat a china dish containing copper powder. You will observe that the surface of the copper powder becomes coated with black copper oxide. This black substance is formed because oxygen combines with copper, resulting in the formation of copper oxide. The reaction can be represented by the balanced chemical equation: 2Cu plus O2 right pointing arrow 2CuO. The copper is oxidized as it gains oxygen during the reaction. If hydrogen gas is passed over the heated copper oxide, the black coating on the surface turns brown as the reverse reaction takes place. Copper is obtained as the copper oxide loses oxygen. The balanced chemical equation for this reverse reaction is CuO plus H2 right pointing arrow Cu plus H2O. In this reaction, copper oxide is reduced as it loses oxygen, while hydrogen is oxidized as it gains oxygen. Redox reactions involve the transfer of electrons between reactants. Here are a few more examples. Chemical equations: ZnO plus C right pointing arrow zinc plus CO, manganese 4 oxide plus 4 HCl right pointing arrow manganese 2 chloride plus Cl2 plus 2 H2O. Zinc oxide reacts with carbon to form zinc and carbon monoxide. In this reaction, carbon is oxidized as it loses electrons, while zinc oxide is reduced as it gains electrons. Manganese dioxide reacts with hydrochloric acid to produce manganese chloride, chlorine gas, and water. In this reaction, hydrochloric acid is oxidized as it loses electrons, while manganese dioxide is reduced as it gains electrons. We often encounter the effects of oxidation reactions in our everyday life. One common example is corrosion, which you may have noticed on iron objects. When iron is attacked by substances such as moisture and acids, it undergoes corrosion, leading to the formation of a reddish-brown powder called rust. Corrosion can cause damage to car bodies, bridges, iron railings, ships, and other metal objects. It is a significant issue, and substantial resources are dedicated to replacing corroded iron each year. Another effect of oxidation is rancidity, which occurs when fats and oils undergo oxidation. This can alter the taste and smell of food products containing fats and oils. To prevent oxidation, antioxidants are often added to such foods, and airtight containers are used to slow down the process. For example, chip manufacturers often flush bags of chips with nitrogen gas to prevent them from getting oxidized and becoming rancid. Understanding displacement reactions, double displacement reactions, and oxidation reduction reactions helps us comprehend chemical processes occurring in various contexts. Whether it's the replacement of one element by another, the formation of precipitates, or the transfer of electrons, these reactions play a vital role in chemistry and have significant implications in our daily lives. That concludes our lesson on displacement reactions, double displacement reactions, and oxidation reduction reactions. We hope you found this video informative and engaging. Thank you for watching, and remember to explore and observe the fascinating world of chemistry all around you.
For more videos, stay tuned with us.